Hi friends, in this video we are going to derive the power equation of cylindrical synchronous motor. Let's see here. I said you in alternator the only difference of motor and generator is that what is the only difference? Here, for example, this is EMF and this is V. If this is EMF, this is V, and the angle between EMF and V is delta. Nothing but here EMF is lagging to the V, but in alternator leading to the V. This is the only difference between these two. For example, if it is taken as V at an angle 0, then this is taken as E at an angle minus delta. This is the very important thing for motor. And next one, generally for motor, E is equals to V minus IA ZS is this. Yes or no? Generally E value is less than V. V is more for motor. Now tell me from this IA ZS is equals to V minus E, and from this IA is equals to V minus E upon ZS. And voltage is the reference, EMF at an angle minus delta and ZS at an angle impedance angle theta. Are you okay? So IA is equals to V minus E at an angle minus delta upon ZS at an angle theta. This is exactly what is IA. But I want apparent power S. S is equals to P plus JQ, of course. P is nothing but VI cos pi, of course. Q is nothing but VI sin phi, of course. S is nothing but not VI. What is S? S is nothing but VI conjugate. So, the apparent power S is equals to VIA conjugate is the formula. Sir, I know IA, but how to find IA conjugate? So tell me, IA conjugate is equals to, this is V minus E at an angle delta and ZS at an angle minus theta. This is what IA conjugate. Conjugate nothing but these angles are reversed. So this is what IA conjugate. Now I want to find out the apparent power from this equation. How? The apparent power S is equals to V and IA conjugate. What is IA conjugate? V minus E at an angle delta upon ZS at an angle minus theta. This is the apparent power. So tell me, what is S? S is equals to V square upon ZS, and this is minus theta in denominator, so it is theta in numerator. Minus VE, nothing but EV upon ZS at an angle minus theta in denominator, so in numerator plus theta. This is the apparent power of my synchronous motor. You should remember this, otherwise you have to derive in every time. You should remember this formula. Right? It is completed, and now we have to find out P. P is nothing but VI cos pi. From that we can write as this. From this P is equals to Can you anyone tell me? Yeah, very good answer. V square by ZS cos theta minus EV upon ZS cos of delta plus theta. This is the power which is developed, or the power of synchronous motor. The power of synchronous motor. Are you okay? Right? Now I want the maximum power output condition, maximum power input condition, because this is a motor, right? So what is the maximum power input, or simply what is the maximum power? Sir, whatever the equation, to get the maximum value, we have to differentiate the equation with respect to variable, and exactly it equals to 0. Yes or no? So tell me what is the differentiation of this one? The differentiation of this one with respect to delta, 0 minus, what is differentiation of this one? EV upon ZS cos theta differentiation minus sine theta, nothing but sine of delta plus theta, and differentiation of delta 1, differentiation of theta plus 0. This is equals to 0. Are you okay? Right? So next, here minus minus plus, so EV upon ZS sine of delta plus theta is equals to 0 is the equation. Are you okay up to here? Now come to here. When this is bring this side, then what is the equation? Sine of delta plus theta is equals to 0. Here two angles are added. When two angles added, is it possible to 0 degrees or 180 degrees? It may 180 degrees. That is the more possibility, right? So tell me what happened. The sine of delta plus theta is equals to 0. 0 in terms of sine. Sine 180 is nothing but 0. From this equation, the condition for maximum power input is equals to theta plus delta is equals to 180 degrees. This is very important for synchronous motor, and delta is equals to theta is the condition for maximum power output in alternator. You should remember that one and this one. Don't confused. Okay? Are you clear? So this is the condition for maximum power input of synchronous motor, which is very important thing. Right? So this is the, what is the procedure to find the condition for maximum power input in synchronous motor. It is clear. Now we have one assumption. What is that assumption? If armature resistance neglected, what happened? Are you okay? Listening or not? If armature resistance neglected, then what is the power equation? Because the armature resistance value is very less compared to reactance. So let's eliminate that armature resistance from this. I'm going to eliminate that armature resistance. If armature resistance neglected, okay, nothing but Ra is equals to 0, nothing but Zs is equals to Xs. If Ra 0, theta is equals to tan inverse of X by R. Something by 0, infinite, nothing but 90 degrees for tan. So substitute these values in our power equation. Now tell me what is power. P is equals to V square by ZS cos 90. V square by ZS cos 90 0 minus EV upon XS, because ZS is equal to XS cos of 90 plus delta. So can you tell me what is 90 plus theta? 90 plus theta belongs to here 90 minus theta, but here 90 plus theta. That is belongs to second quadrant. In second quadrants, all silver. Here sin is the positive, but cos is the negative. So what happened here? P is equals to minus EV upon XS. Cos of 90 plus delta is minus sine delta, because all silver. In second quadrant, only sine is the positive. So tell me what is the answer? Minus of minus plus. So finally the power is equals to EV upon XS of sine delta. This is the power of synchronous motor when armature resistance neglected. Are you okay? Remember this, right? So come here. When armature resistance neglected, we got the power equation P is equals to EV upon XS sine delta. For this, plot a graph for power and load angle. Power load angle curve. If delta is equals to 0, the power is also 0. If delta is equals to 90, the power is maximum. If delta is equals to 180, the power is 0. So the curve is perfectly sinusoidal. What is that? This is perfectly sinusoidal. At delta is equals to 90 degrees, P is equals to P max, that is equals to EV upon XS. EV upon XS, because this is 1. So this is the condition for maximum power. Condition for maximum power for armature resistance neglected power equation. Are you okay? Getting or not? This is very, very, very important power, and this is very, very, very important condition. Right. So we completed the power load angle curve also. Now synchronizing power coefficient. So tell me, what is synchronizing power coefficient? This is which measures the degree of stability, and it improves the stability when PSY is positive. What is PSY value? PSY is equals to dP upon d delta. So tell me, what is PSY? Is equals to differentiation of power equation with respect to delta, EV upon XS of sine delta. So tell me, what is PSY now? PSY is equals to EV upon XS. Differentiation of sine delta is the cos delta. This is PSY of synchronous motor. Can you draw the load angle curve? Draw it. So here load angle on x-axis and PSY on y-axis. So draw the load angle curve. If delta is equals to 0, this is the maximum. If delta is equals to 90 degrees, this is 0. If delta is equals to minus 90 degrees, again 0. So the curve is like a cos. This is the PSY load angle curve. So we completed the power equation and condition for maximum power input, and if armature resistance neglected power equation, and load angle curve, and the maximum power condition, and synchronizing power coefficient, stabilizing coefficient, stabilizing factor, and its power load angle curve. Up to now, the active power theory is completed. Active power story is completed for this. Now we have to derive the equation for reactive power. Just very simple, right? So let's go for reactive power. What is reactive power? Q. Q is equals to VI sin phi actually. But from the apparent power, the reactive power Q, can you give me? Yes, tell. V square upon ZS sin theta minus EV upon ZS sine of delta plus theta. This is the reactive power of synchronous motor. Here again, if armature resistance is equals to 0 or negligible or very small, then what happened? The synchronous impedance is exactly equals to synchronous reactance and impedance angle theta is equals to 90 degrees. This is simply what armature resistance neglected. Then we have to substitute these two values here. So substitute these two values. So Q is equals to V square upon XS. Sin 90 is the 1 minus EV upon XS sine of 90 plus delta. I said you already, all silver teacups. Here 90 plus theta belongs to second quadrant. All silver, nothing but sine. Here sine is the positive. So tell me what is Q? Q is equals to V square upon XS minus sine is the positive and sine of 90 plus nothing but cos. So cos delta. This is actually the power equation. If you modify like a small common value, Q is equals to V by XS of V minus E cos delta. This is also very important. They may ask you problem on this equation. We remember this. Here Q is equals to V by XS, V minus E cos delta for motor. Whereas for alternator, tell me, are you remember? Okay, so tell me, for alternator, V by XS of E cos delta minus V. E cos delta minus V is the very different. Just these two are changes, that's it. This is the reactive power story of cylindrical synchronous motor. This is finally what is the power equation and power load angle curves of cylindrical synchronous motor. Got it? Are you okay? Very important, sir. They will ask you questions on this. Thank you.